Hello, hello, hello. Today we're going to be talking about compound and continuous interest, and we're going to do this in three parts. In the first part, I'm going to show you a little bit of how the compound interest formula is made, and at the end of the first video, I will give you the formula, and then in the second video, we're going to be using the formula. I want to say this just so it's clear. It might be a little bit confusing or abstract as I develop this formula. Students sometimes struggle with seeing how a formula is developed. And so I want you to watch this video and try to follow, but I don't want you to be nervous or anxious if you're struggling to follow me as I build this formula from scratch, because you're not going to be responsible for building this formula from scratch. You're just going to be responsible for using the formula once we've built it. So don't feel too nervous if you struggle a little bit to follow some of the details in this video. So let's talk about compound interest. Compound interest is the type of interest that you will find most often with bank accounts, with student loans, and in general with any sort of interest problems in the real world. So in a compound interest situation, you're still investing a principal amount P. So P is the principal. And then I'm going to use a lowercase I to denote the interest rate per time period. So what happens with compound interest is we have a time period upon which the interest is compounded. Oftentimes it's compounded every month. Sometimes it might be compounded every year or every quarter. It could be compounded every week or every day. And what I mean by compounded is whenever you're owed interest, whether it's every month or every week or every day, that interest goes into the account, and then the next time that you earn interest on the interest that was put into the account. Or if it's a student loan, you owe interest on top of the interest that has accrued. So it's a little bit more complicated than simple interest, and this is generally how things work. If you have a bank account, a savings account that earns some sort of interest, you'll see a small interest payment every month, and that goes into your account, and then the next month you earn interest on all of that. Anyways, let's talk about how this works out. We're going to look at one time period at a time. So you invest P in the very beginning, and then after one time period, whether it's a month, whether it's a week, whether it's a year, you have earned interest on top of that, which is going to be P times I. So you start off with the P that you've invested, and then you've earned P times I for interest, because the interest rate is generally the percent that you've earned, and so we've earned that percent of the principal that we invested. Now there's another way to write this. We can write this as P times 1 plus I. Basically, by investing your money for a time period, it gets multiplied by 1 plus I, 1 representing the 100% that you had put in, and I representing the extra percent that you had for interest. So after one time period, you have P times 1 plus I in your bank account. Now, let's say another time period has passed. What happens then is you still have the amount that you had in the bank before, which is P times 1 plus I, but then you take that amount and you've earned I% interest on it, so you get that same amount times I. Now there's an interesting thing here. Both of these terms contain a P and a 1 plus I, so we can factor out P times 1 plus I. And when we do that, when we pull out the p times 1 plus I, what's left over? Well, this first one is multiplied by 1. So we've got a leftover of 1 from the first term, and we've got this I as the leftover from the second term. So we've got p times 1 plus I times 1 plus I, or p times 1 plus I squared. And so effectively, every time the money is left in for one time period or one compounding period, which is what we call it, it gets multiplied by 1 plus I. So if we were to leave it in for 3 compounding periods, we'd have p times 1 plus I cubed. And if we left it in for n compounding periods, we'd have p times 1 plus I to the nth power. And this is more or less the relationship that we have when we're dealing with compound interest. But I'm going to write the formula a little bit differently, because instead of looking at an interest rate per compounding period or per time period, we're going to be given an annual interest rate, R, and then also the number of time periods per year, which is N. I know this seems confusing, there's so much going on, but let me give you the actual formula and we'll talk about how it's similar to the formula that we've developed. So compound interest is given by the formula A of t, because the amount that we have in the end is a function of time, and it's going to be p times 1 plus r over n to the nt power, where our function A of t is the total amount after t years, and then p is the principal still, and then r is the annual interest rate, and then n is the number of times the interest is compounded per year. So let's say the number of compounding times per year, and t is the total number of years, so the time in years. All right. So there's a couple of things that are different with this formula that I've given you and the formula that we came up with. Both of them start off with p, and in the parentheses both of them have 1. But here, instead of I, I've written r over n. And what this means is r is the annual interest rate, and n is the number of compounding periods per year. So if we divide the yearly interest rate by the number of compounding periods, that gives us the interest rate for each compounding period, which is I. So this is just another way of expressing it. And then, instead of n, we have n times t, because if we have n compounding periods per year, and if we're investing our money for t years, then the total number of compounding periods over the course of those t years is n times t. So this is our formula for compound interest. At this point, you don't need any of the stuff up here. This was just me trying to work out why the formula looks like this. And so in the next video, we'll get a little bit of practice with some actual problems doing some interest calculations.